Enhanced Interior Gateway Routing Protocol. Very interesting in Cisco's realm. In Cisco, we always focus on the Cisco's proprietary protocol. One of the proprietary protocols Cisco has got is EIGRP. So this is one of the Cisco proprietary protocols, but they have made it as open standard now, so that some vendors may use it, but so far no other vendors have tried using this on their device. Only Cisco. Enhanced Interior Gateway Routing Protocol. As we spoke in the introduction class, this is an enhanced version of IGRP, which means the older version of EIGRP is IGRP. Now, this is also coming under category of distance vector. Not only RIP, even EIGRP advertises the network and the metric to reach the network and the gateway via which the network can be reached. Same like RIP, it advertises the next hop and the metric. So this is also a distance vector protocol. But in RIP, if you notice, the router advertises the hop count. The hop count that it gives is the hop count of the router which receives it. For example, if I am a router and you are another router, I'll tell you, for me, 5 hop away, so for you it is 6 hop. So you don't need to calculate how many hops from your side. You simply copy what I'm giving you as your own metric. So your own metric, you don't calculate. I give you. As a neighbor, I advertise you the metric that you should use. Whereas in EIGRP, I don't give you the metric. I simply say, for me, this is the metric. So for example, I'll say, for me, metric is 100. Then you will see, okay, for him, if it is 100, then between me and him, it's 50. So for me, it is 150. You see? EIGRP does some partial calculation. Whereas in RIP, it blindly believes the neighbor. Whatever the neighbor gives, that becomes the metric in RIP. Whereas in EIGRP, the neighbor gives metric to reach some destination. To that metric, the metric between that neighbor and myself is added. That is how my metric is calculated. My metric, I don't depend on my neighbor completely. Partially, I depend. He advertises his metric to the destination. I add the metric between me and my neighbor to what he has advertised. Did you understand the point? So, EIGRP is not learning completely, not fully dependent on neighbor for metric. This also does some partial calculation. That's why we don't call simply as distance vector, we call it as advanced distance vector. Advanced distance vector. Next is EIGRP is fast in convergence. Yes. When you compare to RIP, EIGRP is fast in convergence. How? When a change happens in topology, the change is immediately flooded, triggered, so that everyone will know about the change. When a network goes down, immediately the information about the failure of the link is flooded. Failure of the network or the network going down is advertised. As a result, all will change it. All will change the routing table according to the new change that has happened. Whereas in RIP, if you compare, when a network goes down, after waiting 180 seconds, after waiting 180 seconds, it will decide as possibly now. And then in another 60 seconds, which is totally 240 seconds, the route is flushed out. After that only, if there is a new route available, that can be considered. I repeat, when a route goes down, you need to bring the alternate route into the routing table, for which it takes at least 4 minutes to throw the old route. Only after throwing the old route, the new route can come into the routing table. Whereas in EIGRP, almost immediate, as soon as the primary route goes down, as soon as the route which was known to the routing table goes down, the route is thrown out, because the triggered update, the immediate update which is flooded to everyone, makes the routing table to throw the route which is found dead. As soon as it throws the old route, again the routing table looks into the topology table. Yes, EIGRP maintains backup route as well in the topology table. Not only the primary route, it also maintains the backup route. Backup route. EIGRP maintains backup route, not just the primary route. It also maintains the backup. So when the primary route goes down, immediately it brings the backup route after throwing the primary route. As a result, the packet that was forwarded using the old route now is forwarded using the new route. So very few packet is dropped during this convergence, during this adapting to the network change, during this change of route. Only few packets get lost, not too many, because in few seconds this will switch over. Not like 240 seconds in RIP. RIP is very slow. 240 seconds. Here almost immediate. If there is a backup route, as soon as it learns the primary route has gone down, it throws the primary route and makes the backup route as primary. In this way, EIGRP is fast convergence protocol. We saw in the morning, means your evening, yesterday, EIGRP is a classless routing protocol. So it supports variable lengths of net mask. You can have different length. For example, This picture here, if you see, it is slash 16 everywhere. Here it is slash 24. Yeah. So the length is not the same. Here it is 16, here it is 24. EGRP can support this, which is not possible in a class full routing protocol. Also, if you have a discontiguous network, discontiguous subnet, like mixture of 10, 172 subnet, 192 subnet with various subnet masks, EAGRP can comfortably work. The fast convergence is because you got the backup route. That is what I finished. Maybe when you got disconnected, I might have said about this discontiguous subnet. Discontiguous subnet means you got networks, variable length, and the networks don't belong to the same subnet. Maybe some places you have 192, some places you have 10 network, some places you have 172 network. So when you have mixed of multiple networks, subnets, we call it as discontiguous subnet. EHRP can work very efficiently even in such environment. And EHRP send partial updates. If you take RIP sends a complete routing table, which is going to consume a lot of bandwidth. Not only that, the receiving router needs to process many route information. Whereas in EAGRP, only the change that is happening here and there are sent. Only those changes are sent, not the complete routing table. As a result, the process utilization, the bandwidth utilization is going to be less. Now, I also told you in the network layer we have IP, IPv6, IPX, novel network as network layer protocol. EAGRP supports all this. EAGRP supports multiple network layer protocol. Very good. So I said manual summarization at any point. It supports multicast, unicast instead of broadcast, flexible network design. Now we're switching into the next topic, 100% loop-free classless routing. Like any other protocol, EAGRP also have got loop prevention mechanism. We saw in RIB, you also answered very well when I asked you how loop is prevented in RIB. You said split horizon. Excellent. In EAGRP also we have loop prevention mechanism, which guarantees 100% loopless or loop-free classless routing. What is that? It's called dual. Dual stands for diffusing update algorithm. Diffusing. Let me show you. Dual. Here. They have not given the abbreviation there. Let me show you. Diffusing update algorithm. Yeah. So it is this algorithm which is used in EAGRP guarantees you the 100% loop-free classless routing. Should not forget this. What provides a loop-free classless routing in EIGRP? It is dual diffusing update algorithm. How? How can dual guarantee loop-free classless routing? For that, the explanation will come when we go to this page. This is it. Dual algorithm has got something called feasibility condition. What does that feasibility condition says? The advertised distance of feasible successor must be less than the feasible distance of the current successor route. This is what the dual algorithms condition, which guarantees a loop-free network. We'll talk about that when we go there. It's too early. I'm just telling you that there's a condition called feasibility condition, which is used in dual algorithm that can guarantee a loop-free classless routing. Next, if you compare the LAN configuration and WAN configuration, it's more or less the same. There's no big difference. Easy. See, whenever we speak about WAN, we don't trust WAN. LAN is your own, right? LAN is your own network. WAN is something like we use ISP, some sort of service from outside people to connect to remote office. So there will be some precautionary steps when you talk to someone over the public network. Usually there used to be some precautionary steps, but in EIGRP you don't have such thing. Both LAN and WAN configuration is almost the same. It's the same. Why EIGRP is not following any precautionary steps when it is connecting to the WAN? Because you don't need to enable EIGRP on the WAN side because EIGRP is an IGP protocol. Next, as I said earlier in the introduction to EIGRP class, EIGRP can load balance, can share the load across multiple links, even if it is unequal cost. Even if the cost is unequal, EIGRP can share the load. All other protocols except BGP, they can load balance if the metric is equal. If the cost is equal, RAPE, OSPF, ISIS, EIGRP, they do share the routes. They do share the packet across the multiple paths. But when it comes to unequal cost, when the metrics are not the same to the destination via a different path, only the low cost path will be used by OSPF, RIP, ISIS. Whereas EIGRP can be tuned to even share the load across the unequal cost paths. Question to you. Will EIGRP do unequal cost load balancing by default? Yes or no?
This is what you said, it can be tuned.
Yes.
That means you have to do something for it to facilitate an equal cost.
Correct.
Maybe no.
Answer is no. You're right. What you said is right, because you need to tune it. By default, only equal cost path will be used to load balance. If I have two paths from A to B, I can go this way, I can go this way. If the cost here is 10 and 12, and if the cost here is 11 and 8, going via the bottom path is 19. Going via the upper path is 22. By default, EIGRP will say, I'll go via this bottom path. This is the preferred one. This is default. Not only EIGRP, any protocol will do this. But I can tune EIGRP so that this path can also be considered. Now, will it share the load equally? No. EIGRP is very clever. It says, hey, the cost here is very low. Let me send more packets. Let me send 600 packets this way and 400 packets this way. So this 600, 400, you don't need to worry about. EIGRP does that calculation. It knows which path has got more bandwidth and less cost. According to the capacity, EIGRP can easily do those judgment. EIGRP can easily does this justification and share the routes, share the packets. So it's not going to be equally shared because the cost is unequal. According to the capacity, the path is going to be determined. The amount of traffic in the path is going to be determined. You and I need not to worry about how much percentage. Those things are dynamically calculated and taken care by EIGRP. Now, do you have any question on this page?
No, not yet.
Very nice. You see, when you say flexible network design, you can have any sort of design, like you can have small network, medium network, or you can have many autonomous systems and redistribute routes from one EIGRP to another EIGRP.
Okay, all right.
So let me repeat. You see these clouds? This is like autonomous systems. And the routes of this autonomous system and this autonomous system you redistribute. That's how routes from core will come to this distribution layer. So you may have a core autonomous system and distribution autonomous system, 3 autonomous systems, to share routes between the distribution 1, distribution 2, distribution 3. You may use core, same like OSPF approach, a backbone area, something like that. And you can redistribute, let's say this autonomous system 10, this autonomous system 20, this autonomous system 30, this autonomous system 40. You can redistribute routes between them so that you can learn, and also you can summarize before you send to core, and from core when you receive you can summarize and receive. So you can have any sort of design. There is no fixed design like you have in OSPF. In OSPF it's a fixed design. You must have a backbone area in OSPF in order to communicate between non-backbone areas. But EIGRP is flexible. You don't have something like that. You can have your own design. Did I answer your question?
Yes, but one other thing,
Mm-hmm.
you said manual summarization is also known as interface level summarization.
Yeah.
But question I have, if you have say 100 routes coming with a similar network coming from say where you put distribution one, and you want to summarize all those 100 routes. You said it was on the interface. You would, I don't understand.
Let's see. You got two type of summarization. One, you see R1, R2, R3, and now let's say this router has got 10.1.0.0/16, 10.2.0.0/16, 10.3.0.0/16, 10.4.0.0/16. So how many subnets? How many subnets we have here? I think you are in mute. How many subnets?
Four,
Four.
four.
Now, when you don't summarize, this router 2 will see 4 routes coming from R1. Even R3 will also see 4 routes. And when you go and say summary, auto summary, when you say auto summary in the global configuration in the router mode, when you put this command, what will happen? Both R1 and R2 will receive only the summary route. Do you agree? Sorry, both R2 and R3 will receive only
Yes,
one route, and that will be a summary route
right.
like this: 10.0.0.0/8. Here also 10.0.0/8. Correct? But if I wish to have detailed routes in R3, if I wish to have detailed routes in R3, what I need to do is I need to say no auto summary. I need to say no auto summary so that in R3 I'll get a detailed all 4 routes, but I'll go to this port on R1 and I'll do manual summarization saying, hey router 1, when you're sending on this direction, send like this 10.0.0.0/8. So R2 receives the summary route, whereas R3 receives the detailed route. You understand the use case when I need to use manual summarization? Whenever I want to send to one
Yes,
particular neighbor differently, then I need to use manual summarization. Yeah?
yeah, understand. Yes, understand. Very clear.
Right. So